All right, Chem students, today we're going to talk about dilutions with molarity. You need your blue notes packet and something to write with. Okay, first we need to go over what is dilute and what is concentrated. Now, a dilute solution will contain a relatively low amount of solute particles for a given volume, and a concentrated solution will contain a relatively high amount of solute particles for a given volume. So if you see on the left here, we have a container, which is the same size as the one on the right, but this one on the left has much more solute particles. So that we would say this one is more concentrated than the one on the left. The one on the left would be dilute. It doesn't have very many solute particles. Now, sometimes in chemistry, we need to make a more dilute solution from a more concentrated one. And we would accomplish this by what we say watering down the more concentrated solution. The following formula is how you would do that. Molarity 1 times volume 1 will equal molarity 2 times volume 2. And as an example down here, if you've ever made orange juice from orange juice concentrate, that's what we do. We take the 1 can of orange juice concentrate and we will add 3 cans of water to dilute it to an acceptable ratio to drink. You can't just drink the orange juice concentrate. It's not good. But if you add water to water it down, it comes out just right. Now, for an example, you have a 6.0 molar hydrochloric acid solution, and you want to make a dilution so that you have 1,000 milliliters of a 1 molar hydrochloric acid solution. What volume of 6 molar hydrochloric acid will be required? So let's look and label our problem. So you have 6 molar, that's M1. You want to make a dilution so that you have 1,000 milliliters. There's V2, so that's going to be the new dilution. That's what we're hoping for. And M2 would be 1 molar, so that's the new molarity. So we know that these are the goal. We need to know what volume of that original hydrochloric acid would be required. So we're looking for V1. So this is our formula. M1 times V1 equals M2 times V2. We're going to rearrange it so that V1 is by itself. And we're going to plug in our numbers. So 1.0 times 1,000 divided by 6.0. Our answer comes out to be 167 milliliters. Now the next part of this question, they ask us how much water will be required. Well, this is how much of the original acid we were going to use. So we needed 1,000 milliliters for our total solution. That was the goal. We're going to use 170, and I used 170 because of sig figs. 167, 2 sig figs here, 2 sig figs here. So 1,000 minus the 170 means that the remaining volume from that 1,000 milliliters will be 830 milliliters of water that was used to dilute it. Okay, that's it for today's lesson on dilutions with molarity. Work on the corresponding page in your practice packet, and we'll see you for the next video.